Hey there. I'm going to go ahead and do problem 1 on the 311 notes. This is on related rates. And related rates are when you are comparing two, typically two or more rates that are occurring in one scenario. And your job is to calculate an unknown rate of change in terms of other rates of change that are known. These are word problems, applications, okay? And so I'm going to do one with you today. I'm going to do a couple more with you tomorrow, and then we're going to be practicing these word problems. So if something comes up and you're thinking, oh man, I wish that I could ask her this question, make sure that you mark down what you want to ask me, and I will answer that question tomorrow. All right, this is the area of a circle. All right, so this is a problem related to the area of a circle. It's a typical problem. The radius of a circle is increasing, okay? And so the radius of a circle is increasing at a constant rate of change. So the radius of a circle is increasing at a constant rate of 3 inches per minute. That tells me I have a rate, okay? Increasing at a constant rate. Plus the unit, inches per minute, also tells me that I'm dealing with a rate. At the moment, when we talk about this moment, it means like in this exact moment of time, okay? The radius is 8 inches. Notice there's only 1 unit on that, okay? So that's not a rate, it's just 1 unit. A rate compares 2 units. The question then says, what rate is the area of the circle increasing? Okay. What this means is that I get to first come up with a couple variables, okay? And anytime I see this word moment, I know I'm dealing with time. And so I'm going to say t is going to represent time. It also seems as though I have radius, but radius is known. The radius is 8 inches. But I do know that I have a rate at which the radius is changing, and that is with respect to time. Notice I have the unit for the radius in inches, and then per minute tells me that I do have a rate, okay? And so I'm going to say dr dt. That's my rate. Okay, so rate of radius changing, which means if I'm taking the derivative of the rate at which the rate of the radius is changing with respect to time, I should have a value representing radius. So I'll use r to represent radius of the circle. It says, what is the rate of the area of the circle? How is that increasing? So again, I have this rate, the rate at which the area is increasing with respect to time. So that's the rate of the area, which means I'm going to have an a function with respect to time. This is related to area. The area, what is the area given a specific time? So these are definitely adding the layers. We have time happening here. We have a radius at a given time. We have an area of a circle at a given time. And we have information about the rate at which the radius and the area are changing. Other things I'm expected to remember are things like the area of a circle. So if I recall from geometry, the area of a circle is a equals pi r squared, okay? And so this a is really like my a of t. It would be like saying, okay, my area with respect to time is equal to pi times my radius with respect to time squared. Okay, so everything is with respect to time. What is happening at a given moment in time? And I need to evaluate, what rate is the area of the circle increasing, which means, and I'm just going to make a note here, this means that I am trying to find dA dt. I'm trying to find a rate, and a rate is a derivative Okay, and so I'm trying to find that derivative, that dA dt, the rate at which the area is changing at a specific time, so with respect to time. So that means I need to take the derivative with respect to my independent variable. And remember, in this particular case, time is my independent variable. So I'm going to take the derivative of each term with respect to time. The derivative of a, well, a is not the independent variable. The derivative of a, though, would be a prime or dA dt. Some people prefer a prime. I'm good with that. A prime of t. Okay, that would be this right here. This is the same as saying a prime of t. The derivative of a is a prime, okay, equal to, okay, now this feels like a product, but it's not really a product, and this is not really a product because remember, pi is a constant, okay? And so when I go to take the derivative of pi times r of t squared, remember I'm going to use my power rule. I'm going to multiply 2 times the coefficient, which is pi, to the first. But see, r is not the independent variable. I also need to multiply by the derivative of r, and the derivative of r is r prime of t, which is the same as saying dr dt, which I write because that's what we wrote over here. Dr dt is also r prime. Okay, and now I have information that I can fill this in, right? So the big idea is I had to come up with a formula. I took the derivative of that formula to determine rates. I'm trying to find the rate at which the area is changing. So I'm trying to find a prime of t. Okay, I know the rate at which the radius is changing, and I know at that particular moment in time, I don't actually know what the moment in time is. Like, I don't know if it's happening at minute 1, minute 2, minute 3.5, but I do know that the rate at which the radius is changing is a positive 3. And it's positive because it says that the radius is increasing at a constant rate of 3. And then it says at a moment that the radius is 8. And now when I multiply this together, I get 8 times 3, which is 24, times 2, which is 48 pi. And so at the moment that the radius is 8 inches, I have an area that is changing. The rate at which the area is changing, that rate of change for the area is 48 pi. Now I need to get my label correct, okay? The label on the rate at which the area is changing, well, it's going to be something per something, okay? A rate of change is the change in y units, so the change in area, and the unit for area is inches squared per, and the time unit, that independent variable unit, is minutes. And so this would be my final answer. The rate at which the area is changing at the moment that the radius is 8 is 48 pi inches squared per minute. Okay, so again, big idea. We come up with a formula if one is not given. We find the derivative of that formula with respect to time. Time is our independent variable. We fill in the pieces we know and evaluate, and we put a label at the end. All right, we'll do a few more problems tomorrow.